Solibri, tool for checking model quality, accessibility, and operational safety. This training material is presented by Nitz, Solibri, Inc. Short Solibri overview. Solibri, a part of Nemetschek Group, is a quality assurance tool well known throughout the industry. Solibri is IFC-built software where user can do visual reviews of singular IFC file or federated model. User can run rule-based checks for data validation, logical functions, and geometry-based checks, and combine these rule templates into sophisticated logical quality control processes throughout the whole building process. We have 4 different options of our software, products, and here we are focusing on Solibri Office, which contains the rule-based checking. As a little detail, we found out that in year 2024, 4.6 million hours of usage and 3.2 billion issues were detected with Solibri. In which use cases can it be applied? Solibri is used widely among the construction industry for visualization and quantities. There is engineering, architectural, BIM management. In the user base, they have different needs. The common thing is they want to have visualized data, see structured data, collaborate with other stakeholders, and use rule-based checking to ensure their requirements. Now, new user group is authorities, reviewing the project visually, validating the requirements, and communicating the findings with the other participants of the project. Who can apply? Almost anyone. There is no limitation who can use or benefit the product. The product is versatile and it can be used from the facility management owners to the quantity consultants, estimating the costs, experts, engineering, running simulations, and now authorities doing permitting or other regulatory tasks. Solibri offers a wide range of tools with easily customizable user interface and resources. Solibri installer contains default resources and tools you need to run your quality assurance, and you can modify and adjust those tools according to users' your own local needs. So we have examples of rule sets, we have templates and libraries available, classification examples which are related already to the generic rules, and information takeoffs, collecting the information that is structured with the classifications. And of course, we have examples of different roles indicating the tasks that one has to execute during the check. And of course, a collection of example files to try out and experiment software. How Solibri fits into the whole process. When you're making the decisions, you have different stakeholders. You have construction and manufacturing, operations and maintenance, telling what are the requirements for the project, and nowadays also authorities with the code compliance. So BIM utilization is quality control, schedules, cost estimation, quantities, analysis, management, planning, and life cycle estimations, and now also building permitting. Those are giving the requirements for the project. And how to meet the requirements. So Solibri in the middle here is a quality gatekeeper with its tools and providing this detailed information to BIM authors, architects, engineers, and other designers. So they can use Solibri to ensure that their BIM models are intact when they go further to production, installation, on-site, and to the end users. The following content is focusing on Solibri rule-based checking, process options. First, we see Solibri Office Desktop, and we compare it with the checking as a service process. We see also Solibri Office Desktop rule creation process versus BCRL-based process, which is new and developed in a core project. Here we can see typical workflows for Solibri. The authoring tools provide IFC exports, which can be opened in Solibri environment. In the desktop, you can review, federate the models, compare the IFC models, and check in details what happens in that design. We have the role, as mentioned earlier, a toolkit concept for collecting the tools for this specific purpose that you are having at the moment. Typical process goes through classification, where you can organize and restructure the data and even add additional tags to your billing elements. You can run through the checking, link the classification names in checking, so you are checking elements with certain classification tag or name. And you can collect information, takeoffs, the quantities, using the structured data in there, and communicate the results, if found any, through the BCF tools to the author again. The optimized way, as an example on sites, is to get the IFC export and go to the information takeoff, get the quantities out, visualize the situation, and report it to the needing stakeholders, and also to communicate to the author if something is found. Of course, some cases require classifications. It's easy to classify and visualize content for the good information takeoff. In permitting process, the current process goes directly to the checking. You open the extension, the checking rule sets, and the IFC file. You go to the checking, run the checking, generate the issues, collect them into communication, and deliver the BCF file to the author, who provides a new IFC export after revisions are done. In Solibri, generally, there is no one specific way of doing things. So the user can decide which steps do they do or need to get out the best of the product and their design. So it's very versatile and customizable content that you can create. The checking process starts in a checking layout, where user can see in a desktop environment the rule set. They can see the results and the details of that result. The checking is started from the check model command, and the results are shown as traffic lines. Each line has to be manually browsed and analyzed into an issue. Here, the user can check out the box here and create a node issue to be communicated forward. In Rava 3 project in Finland, we decided not to use any classifications. Any of these rules are not linked to classification details, so all the classification data has to be already done by the author in the IFC file, so we can validate if the data is properly created in correct location, in correct format, and as is among the allowed values. Here we can see the issue management, the details of delivered issue, and the user fills in the details in a desktop environment and collects those issues into logical presentations, which can be reported in BCF format. When we compare this to a checking as a service, user cannot create the issues, has no power over that. Every issue is returned after the checking. User has to analyze the issues and they can decide whether or not they communicate it forward. Details cannot be changed there. In Solibri environment and most of the authoring tools, users can review the BCF file content and do the necessary changes. The rule creation process starts with the analyzing the rules, mapping the target building elements to IFC classification, and now we are talking about desktop process as it currently is. We test the file, we parameterize, we test the file, and finally create the logical rule set structure for checking. And if there is no details enough that we need, we either have no rule, we have to do a customized solution and run the customized solution for checking. In BCRL, we have the conversion, software-based BCRL conversion. We do the term implementation in Solibri. They are tested and then they are returned to and converted into Solibri rule sets and tested. And then we have the rule set, which looks exactly the same as in desktop environment. For this type of checking, we have created prerequisites for checked objects. And this example here is based on Rava 3 Pro project. So we are looking for details to identify the checking objects, what we are checking, building elements of certain type, what kind of elements, what kind of criteria do they have. They have to have the information if they are external, load-bearing, handicap accessible, if they are fire rated, part of the fire exit, and so on. And also where they are located and what spaces they are related to. You can see more details in Rava 3 Pro, National Development for Automated Building Permitting. There's a detail in Excel format what kind of information we are requiring on different elements. The rule definitions, here are the examples, how they are created. And in the Finnish pilot, we did the following clauses according to Finnish Building Act. Clause 34, operational safety, section 117E, and 35, accessibility, section 117D. And examples of the entrance and passageways. Here you can see the entrance. First definition for the entrance, the minimum width, height, threshold. And within these details, we can see that it's related to a specific space, foyer, or entrance hall. And then we have the details of the door parameterized in this table. The next, we have general doors. We have the requirements for them in height and width. And then we have example of the space requirements for the corridors and toilets. In this case, this is toilets, so that it is wheelchair accessible. And finally, stairs and ramps example. And here we can see the mandatory details of the core data of the project that we need to validate as well. We also tested this in our pilots. How can it be implemented into the model in authoring tool and how it can be checked. Here we have a very simple description of non-automated submission process. We hear the applicant delivers the material to the permission granting, and there the PDF is the main format at the moment in Finland. They have the optional possibility to check in the desktop if they want to, and the applicant has the similar option if they want to check their design IFC. And this information is delivered manually or in digital documentation to different instances of public authorities, data network environment, and municipalities. In Solibri Checking as a Service pilot, we have the cloud permit handling the permitting material. Applicant is delivering the IFC file with the PDF files, and Solibri is automatically running the IFC validation for this content. And after that, the user and the authority have the optional checking service available, so they can run the accessibility and operational safety as an example. The IFC validation looks for the core information and the BIM quality of that design, so that it contains the necessary data for more complex regulatory texts. And this information is delivered via APIs to different instances. Mr. Ilkka Mattila will tell more about that in his presentation. Short comparison between the desktop and checking as a service. In desktop, applicant can work on their desktop license. They need a bit more skilled users to handle the checking than in a CAS option, and applicant can run checks in quick cycles. Or authority needs a desktop license as well, and they need the skills to handle the model, and BCF must be delivered via email or uploaded to shared data storage. The benefits of the desktop is the author of the rule set can do the rule configuration and do decisions and ignore irrelevant issues easily, and issues can be filtered and categorized by their severity. User can also edit, create, and add content to an issue. In checking as a service, both applicant and authority has to have the access to permitting portal. They have to retain basic levels of skills to use the portal only. Applicant uploads the file. File is automatically checked. No visual details shown. No 3D available during the checking. Checking results are instantly available, and there you have a simple 3D representation of the model. Checking results can be commented and communicated by creating the BCF file. Applicant can open the BCF file in the authoring tool and submit a new version to the portal again. Applicant can run additional checks anytime necessary. This is all. Thank you for your attention and time.